I'm going to start the sensor, and then I'm going to use this to launch them off of each other. And let's see how this goes. Okay, so let's stop that. So, first thing to notice, before we launch these things, there was zero total momentum. After launching them, they're nearly the same mass, they launch in opposite directions and nearly the same speed. We still have zero total momentum afterwards. Right after the launch, the total kinetic energy was 0.084 joules. That's what we're going for. 3, 2, 1. Okay. Once again, we still have conservation of momentum. And if I use this feature here, looks like we got 0.088 joules when we use the high masses.
So, garbage. So, just garbage. Alright, so I did attempt partial response. So PhysicistMichael did write a lot of crap, and I haven't even read it, frankly, some of it. This is equivalent to saying if you have the same amount of fuel but twice the mass, the object should be launched at half the speed. Yes, exactly. Conservation of momentum. This is tested in the compressed spring. Is our fuel in the case? Exactly. And somehow your fuel produces different amounts of momentum. I'm saying that's ridiculous. I ran this experiment with various masses. Yes, sloppily not chosen to be, twice as massive, or a quarter, or some round number. Both low mass and both high mass and different mass cases. And it was the kinetic energy that matched up. And I'm saying that's a flaw in your experiment, frankly, because it's wrong. And if I could test your experiment in some way, then I could show you how it's wrong, because I don't think the frame rates, or I don't think if you used a stroboscope that you could defend this, because it doesn't happen on pool tables, it doesn't happen anywhere else. Okay, a factor of 1.6 decrease, very close to square root of 2.7, which is 1.64. Yeah, I'm saying these results are not real. Okay, I'm sorry. This is just showing how experiments can be done poorly enough, and that the confirmation bias guarantees people celebrating their victory. And then I can show these same experiments done by different people to get completely different answers. So I'm just going to illustrate experiments that have been done by Professor Lewin and others, so we know how these experiments come out. Alright, so okay, now all I do is I take the 10 mass at one side and I put a 5 mass on the other side. Now, Professor Lewin's done this experiment, so we know that the momentum goes 50-50. That this will go twice the velocity of this. So this 10 side is going to go 0.5. The 5 side is going to go 1 again. So I go from 5 masses to 2.5 masses. And now I'll double my velocity, okay? And now I'll double my KE. So now I have twice as much KE as I started with here. So somehow I'm gaining more KE, and all I did was change the size of the masses on the spring.